All right, good afternoon. Happy Wednesday. Today's that long, I have to go through all the periods. Anyhow, a couple things. On Sunday, I spent 12 hours going over exams and stuff, and I'm pretty much over it, you guys. The test generators are working properly. For the most part, they're inputting things incorrectly. So, and I'm having to research when somebody turns in something late. I'm having to write messages, and it's just sucking up hours of my life. So, you cannot turn in assignments late. I always get a message. They've turned this in 5 hours late. They've turned this in 6 hours late. They've turned this in 1 minute late. I'm not going to accept it. So you're going to get a 0. As far as the scratch paper goes, I'm trying to monitor the exams. So I'm giving you a 40-minute test in 60 to 65 minutes. So I'm telling you what I expect. I expect you to do the test in 60 minutes and turn in your scratch paper on time. If you do not turn your scratch paper on time, you're going to get a 0. I hope I'm making myself completely clear. It's just ridiculous what's going on right now, and I need you all to get on the same page. Now, this isn't everyone. There are students who have never sent me a remind message. There are students who have never sent me an email, and those students are getting 90s and 100% because they do the work. They do the online problems. They know how to input their answers. Please get in line. I'm going to say it one more time. I'm not accepting late work assignments, and I'm not taking late scratch work anymore. Your work has to be done on time. So the other thing that's really bothering me that I want to address is that your browser has to be Google Chrome. That's why I told you to get a Chromebook and a hotspot. If you have $1 million device and it's not working, it's because you're using Microsoft, you're using Windows, Microsoft stuff, or Internet Explorer. You have to use the Chrome browser. So if you're having issues, that's a major part of the problem. So make sure you have a Chromebook. Make sure you're using the Chrome browser. And if you're not, make sure you're using it on your own device. All right. So I'm going to teach lesson 5.2 today. I'm not going to get through the whole lesson, but I do like this lesson a lot. There's a lot of awe moments in this lesson, because what we're going to do is we're going to look at higher degree polynomials. So we've looked at linear, we've looked at quadratics, we've looked at cubics, and now we're going to look at 6-degree polynomials, 7-degree polynomials, high degree polynomials. And I'm going to show you some tips on how you can make these difficult graphs. You can make them really easily by just knowing what you're looking at. This is lesson 5.2, graphing polynomial functions. Okay, this is California Common Core Standard F.IF.7C. I'll be honest with you, the book is really confusing. I recommend you don't read the book. I would just look at my notes and or watch the YouTube video for the. I'm going to be real clear. I'm going to be very specific about things. I'm going to use proper terminology and language. And so everything you're going to need is in your notes. Or if you need to watch the YouTube video, you can watch it again. So there's this umbrella, and it's the umbrella of polynomials. So you already know about a few. You know about linear, quadratic, cubic. In this lesson, we're going to look at a 4th degree polynomial, which is called a quartic. And we're going to look at a 5th degree polynomial, which is called a quintic. And we're going to also look at 6th degree, 7th degree, 8th degree, so on and so forth. Notice the ones that have special names. The minute you go past 5, you just call them 6th degree, 9th degree, 10th degree polynomials. So you know a line, it's like that. You know a quadratic. The cubic, like that. So the quartic, like this. Do you notice anything about these graphs? Quintic. Sixth degree. Notice anything? Notice anything as the degree gets higher and higher? Notice anything at all?
The humps are more
There's what?
like U-shaped.
Yep. I call them loop-de-loops. Some people call them curves. The name for them, they're turning points. So a turning point is a point where the graph changes direction from decreasing to increasing, or from increasing to decreasing. They're called turning points. So you're right. As the degree gets higher, there's more turning points. I do want you to notice that. Okay. What else do you notice? Do you notice anything about the in behavior?
The end behavior alternates.
Okay, what do you mean by that? What do you
Like,
you're right.
if one of them's going down and then the other one's going up.
Okay, can you be more, you're right. Be more specific, please. Like this guy is going down, and he's going down on the left and up on the right.
I want to say like the odds are going down on the left and up on the right, and then the evens are going up both sides.
Yes. The odds down and up. The evens are going up on both ends. So look at this. Watch, you already watch this. You already know how to do this. Watch. X to the 57th power. What's happening at the end, on the ends?
The left side's going down and the right side's going up.
That's right. Now we don't know what's going on in here yet, but it's definitely going down and up. So what do you think about this guy? X to the 100th power. What's happening?
Both endpoints are going up.
And like I said, we don't know what's going on in here, but we know that the endpoints are like that. That's very important to know. That's valuable. It's going to save you a lot of work knowing that. So just to reiterate, if it's an odd degree, it's going down and then up is the end behavior. If it's an even degree, it's going up on both ends for the end behavior. I just erased it. I meant to say one more thing. But guess what? The number of turning points is 1 less than the degree. So let's say you have a 6-degree polynomial. There's at most 5 turning points. There could be less, but there's at most 5. If you have a 100-degree polynomial, there's at most 99 turning points. If you have a 57-degree polynomial, there's at most 56 turning points. Pretty cool, right? Here's something even cooler. The degree matches the number of solutions. So if you have a 57-degree polynomial, there's 57 solutions. That means it could possibly be crossing the x-axis 57 times. If you have a 9th-degree polynomial, how many solutions do you have?
9.
9.
How many turning points at most?
8.
Yep, and I'm going to write all this down. I'm just kind of quizzing you right now. So I'm going to write it all down, so don't worry about it. Let's take a look at a polynomial function of degree n. So n could be 100, n could be 30, n could be anything. Very technical. The polynomial in terms of x looks like this. A sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot, 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 plus a sub 2 into the 2 plus a sub 1 into the 1 plus a sub 0 x to the 0. Here's some vocabulary for you. The highest power is the degree. This number being multiplied to the highest powered variable is called the leading coefficient. These guys that are separated by pluses and minuses, these guys are called terms. And this guy right here, isn't this really a sub 0 times 1? It's called the constant term. It's a number. 5, -7, 4, 42. So there's the vocabulary you need. The highest powered variable is the degree. The number being multiplied to that variable is called the leading coefficient. These guys are called terms, separated by pluses and minuses, and that is the constant term. So they're going to ask you to classify (2x plus 4x cubed minus 1). They're going to want to know what is the leading coefficient. They're going to want to know what is the degree, the number of terms, and the name of the polynomial. The first thing you want to do is put it in descending order according to the powers of x. So how would you write that? This is a polynomial expression. How would you write it? Don't look at the numbers at all. Just look at the variable powers.
Would you do x3 plus x minus 1?
But it's 4x cubed.
Yeah.
Plus 2x minus 1. Okay, now we can state these. What's the leading coefficient?
(4x cubed).
It's the number. It's the number.
So 4.
4. What's the degree?
3.
How many terms are being separated by pluses or minuses?
3.
Okay, now let me tell you how to name this. The name is the degree and then the term. So the degree is a cubic. And since there's 3 terms, it's a trinomial. So once again, there's the name, has to do with the degree, cubic, quartic, quadratic, and that has to do with the number of terms. And there's only 3 options: a monomial, a binomial, or a trinomial. After that, you just call it a polynomial. Okay, let's do another problem. You're going to put this in descending order according to the powers of x. So what would you write? Come on, you guys. What's the highest power of x?
7 cubed.
The highest power of x. The highest
5.
power of x.
Or x to the quant, or how would you say it?
X to the 5th.
X to the 5th
Go ahead.
plus 7x cubed minus 11x squared.
Okay, does everybody understand what you're doing? All right, I'm going to abbreviate these: leading coefficient, degree, terms, and name. What is the leading coefficient?
Wouldn't it be 1?
What is the degree?
5.
How many terms are there?
4.
And when we name this, we're going to call the degree would be a quintic. And 4 terms, there's no special name. Remember, we can only write monomial, binomial, trinomial. So you would just say a quintic polynomial. All right, does anybody have any questions about this? There's some hesitation, so I'm not sure if you're confused or you're bored or what. I'm not sure. Anybody have any questions about this? Can I erase this?
Yeah.
All right, now I'm going to write some things that I mentioned earlier. There's a bunch of terms for solutions. So solutions mean x-intercepts. Solutions mean answers. Solutions mean zeros. Solutions means roots. So the number of solutions and factors match the degree. And I just mentioned this earlier, that the degree tells you the number of solutions. The next thing I said is a polynomial of degree n has at most n minus 1 turning points. So for example, if you had a 10th degree polynomial, you would have at most 10 minus 1 or 9 turning points. If you had a 15th degree polynomial, you would have at most 15 minus 1 is 14 turning points. Okay, now I'm going to talk about something really important, and it's called multiplicity. But before I do this, I just want to go back to some things we've done, just to remind you that we've done this, okay? All right, everybody just watch. Don't worry about writing anything down. Remember when we set things equal to 0 and we use the zero product property to solve? Remember that? Remember I asked you what the solutions were? And you told me, what are the solutions on this? What makes this 0?
2.
And there's another 2, right? But we didn't write it, remember? We just wrote it once, remember?
Yeah.
Well, this has a multiplicity of 2. But we only wrote it once. That multiplicity is going to tell us something now. So let me just make up a problem. And we're going to do a bunch of these, so don't worry about writing this down. First of all, just guess. What do you think the degree is of this? If I multiplied it back, this is factored form. If I multiply out, what's the degree? Like if I foiled this, you'd have an x squared, right?
Yeah.
X squared times x squared, wouldn't that be a 4th degree polynomial?
Yeah, I was debating on whether saying 2 or 4.
What's that?
I was debating on whether saying the degree was 2 or 4 because of it.
Well, if you multiply this all out, you're going to get x to the 4th. So what if I change this to a 3, a 7, and what do you think the degree is now? What's x times x times x times this 7 times that? Don't you think it's going to be 11? If you were to guess when I multiply that all out, if you're looking at the x's, wouldn't that be, there's 3 x's there, there's 7 factors there. It's like 11. You guys with me or no?
Yeah.
Wait, I don't really understand that part.
Let's go back. What do you think the degree is of that if you multiplied it out?
Three?
Yes. 3. What do you think the degree of this is if you multiply it out? If that was x to the 4th, wouldn't it be x times x times x times x times that factor times that factor? So what do you think? How many solutions would there be?
6.
6. Right?
Yeah.
Okay, now watch this. If you have even multiplicity, the graph is going to touch the root and turn. And to say this in mathematical words, it's tangent to the root. If you have odd multiplicity, the graph is going to cross the root. And what that means, it will intersect the root. I'm going to put this in a box. Did you get all that written down? Okay, let's look at this. First of all, what do you think the degree is of this?
4.
4.
So how many solutions do you have?
3.
5.
How many solutions do you have if the degree is 4?
5.
Didn't we say that the degree matches the solution? Matches the solutions, the degree matches the solutions. So how many solutions will you have?
4.
4.
How many zeros will you have? 4. How many roots will you have? 4. How many x-intercepts? 4. 4, right? 4?
Yeah.
All right. So what are they? What are the solutions? What makes this 0? Now there's 3 of them. So what makes that x 0?
0.
Okay, right. What makes that x 0?
0.
What makes that x 0?
0.
What makes that x 0? -1. Those are your 3 solutions, right? Your 4 solutions, right? Yes?
Yeah.
And we don't like to repeat elements in a set, but we are going to look at the multiplicity. So at 0, the multiplicity is 3. What does that tell you about the graph? Is it going to touch or is it going to cross?
Cross.
What's going to happen at -1?
Cross.
Now, do you realize what's going on here? We can actually almost see what this graph looks like. Watch. So without a calculator, without doing a lot of work, we know that a 4th degree polynomial goes up on both ends. And we know that it has at most 3 turning points, don't we? Yes or no?
Yes.
So we know that this thing goes up on both ends. I picked a hard one. I picked a hard one. All right, whatever. Okay, and our solutions are 0 and -1. And we know at -1 it crosses. And at 0 it crosses. And it looks like a parabola, but we really don't know what's going on here. And most of the time these guys look kind of flat. And not only that, but it could look like this. We don't know. We'd have to investigate it further. So we don't know what's going on there. But the graph looks something like that. I picked a bad problem. Let's try another one. Let's try a better one. I wrote down the wrong problem. Let's try that one. See if I can get something easier. What do you think the degree of this guy is? Like if you multiply that all out. Yep. And you know that it looks like this, right? In behaviors up on both ends?
Yes.
At most 3 turning points? Okay, what are the zeros? What are the solutions? What are the roots? What are the x-intercepts?
4.
Okay, what are they? What makes a 0?
0.
How many are there?
2.
What makes that 0?
2.
What makes that 0?
-3.
Okay, when you look at the multiplicity, at 0, what's happening? Is that even or odd? How many are there? How many number zeros are there?
2.
So what's even multiplicity say?
It touches.
It's tangent. What's happening at 2? How many do you have? You only have 1. So what happens with odd multiplicity?
It crosses.
That crosses.
Yep. And what happens at -3?
Crosses.
It crosses.
Yeah, so without a calculator or anything, let's take a look at the graph. Now we know the end behavior goes up on both ends, right? And our solutions are 0, 2, and -3. So what are you doing at -3, class? Hurry, tell me.
It's crossing.
What's happening at 0?
It touches.
And what's happening at 2?
Crosses.
It crosses.
So doesn't your graph look like that? I mean, we don't know how low this thing goes, but we do know it looks something like that, don't we? Pretty cool, right? So we just graphed a 4th degree polynomial pretty simply. So let's try something harder. Let's try something harder. what do you think the degree is? So this is in factored form. So they're not having you factor, it's already factored. If you multiplied all this out, what do you think the degree is? X times X times X times X minus 5 times X minus 5 times X plus 3 times X plus 4 plus X plus 4.
8.
Yep. Right? 3, 4, 5, 6, 7, 8.
Yeah.
Yes or no? Okay, what are the solutions then? How many solutions do you have?
8.
8.
Okay, what are they?
0. 3 times.
Go ahead, I'm listening.
5 2 times. And -4 3 times.
So when you write the solutions, we're not going to repeat elements. So these would be crossed out, but for the multiplicity, we're going to use them. So what's happening at 0? Is it touching or crossing? Well, what is the multiplicity?
It's crossing or intersecting.
What's the multiplicity?
Oh, 3.
Right. So it crosses, right? The graph crosses. What's happening at 5? Well, what's the multiplicity?
2.
So it's even. So what is it going to do? Be tangent?
Yeah.
Okay. What's happening at -4? Well, what's the multiplicity?
3.
So what's it going to do?
Cross.
All right. So let's look at the graph. So once again, this degree is even. 8 is even, right? At most 7 turning points. It goes up on both ends. So our solutions are 0, 1, 2, 4, 5, and -4. All right. So what's happening at -4?
It's crossing.
What's happening at 0?
Crosses.
What's happening at 5?
It touches.
So doesn't your graph look something like that? Now, we don't know how low this valley is or how high that hill is, but it does look something like this. And the other thing is we're only seeing 1, 2, 3 turning points, but like I said, we don't know what's going on. This thing could be doing things like this. We don't know. We don't know what's going on in between. We have to investigate it further. But we do know that it's crossing through -4, it's crossing through 0, and it's tangent to 5. And if you're curious, you could put this in the graphing calculator and see what it really does look like. But you have to graph these by hand for me. You have to show me this work. You want to try one more?
Yes, please.
Yeah.
Yours aren't going to be this hard. Okay, we keep doing even ones. Let's do something else. What about this one? What do you think the degree is?
5.
What are the zeros?
0,
What makes a zero?
1, 0.
What makes that zero?
3s, 2. There's 2 3s.
What makes that zero?
2 negative 4s.
Okay, when you write these, you're only going to write those once, but we're going to use the multiplicity. What's happening at 0?
It crosses.
Because it's odd, right? So there's only one 0, so that means it crosses. How many 3s are there?
2.
So that's even. So what's that mean?
With touch or tangent.
And what's happening? How many negative 4s are there?
2.
What's that mean?
Tangent.
Touches.
Touches. All right. So what do you know about a fifth-degree polynomial? Who does he look like? He looks like somebody you know. What does a fifth degree look like? He doesn't look like the cubic? Yes or no?
Yeah, because it's odd.
Yeah, and there's like 4 turning points. 1, 2, 3. That should go up. All right. So it's going to go down and up. So our roots are 0, 3, and negative 4. Okay, so we're starting down this time. So we're starting down, right? So what's happening? We start down, and what do we do at negative 4?
It touches.
Okay, and then goes back. Okay, then what's happening at 0?
It crosses.
And what happens at negative 4? Positive 3?
Touches.
It touches.
So there's your 4 turning points. It probably looks real close to this. See, there's 1, 2, 3, 4 turning points. So it probably looks real similar to this. Can you guys see it?
Yeah.
Pretty cool, huh? So like I said,
Yeah.
we don't know how low this valley is or how high that is. We'd have to investigate it, but it looks real close to this. And next time when I talk to you, the next lesson, I'm going to talk about global and local max and mins. So global and local, maximum and minimums. So that's it for today, though. Make sure you get on the lesson. Just because it's not due right now doesn't mean you wait till the last minute to do it. You get started on the lesson, you work on the lessons every day. All right. Okay, if you want to hang out with me, you can. Otherwise, I will see you next time. All right, you guys have a good day. I'm going to turn off the recorder, but you can hang out with me if you want.
All right. Bye, Miss Birch.
Bye, guys. Have a
Bye,
good
Miss
day.
Burt.
Bye, guys. Have a good day.